start.
Okay, today I'll be teaching you guys RGP fitting and the TLS. So basically, I'm gonna explain what is TLS and how it has effects when it comes to fitting of an RGP contact lenses. So we're gonna start by demonstrating the difference between an RGP lens and a soft contact lenses. First of all, I have a cornea. This is a cornea. So when I fit a soft contact lenses on this cornea, it's gonna conform with the cornea. That is soft lens for you. It's gonna conform with the cornea shape. So this is another cornea here. So when I fit an RGP lens on this cornea, it's not gonna conform with the cornea because an RGP lens, they are rigid gas permeable lens. It maintains its shape whenever it's being fitted on the cornea, meaning that whenever you fit an RGP lens, there is a space in between the back of the RGP lens and the anterior part of the cornea, just like as you can see. Now, this space in between the back of the RGP lens and the anterior part of the cornea is being accumulated with tear film. It's been accumulated with tear film, so which is part of the viewing system. So this tear film here being accumulated in front of the eye has its effect, and it creates what we call a tear lens. So this is tears. So this tear lens can be either positive or negative, which I'm going to explain in a bit. Now we have understood the difference, how the soft lens works in the eye and how the RGP lens works in the eye. So this will be our point of concentration today. So I'm going to simply demonstrate how we can have a positive tear lens and a negative tear lens in the eye when fitting RGP. Now I go again. This is the cornea. Before then, I need to let you know that RGP lens can be fitted steeper than K. Whenever it's fitted steeper than K, we are creating a positive tear lens. Whenever an RGP lens is fitted flatter than K, we are creating a negative tear lens. Finally, an RGP lens can be fitted on K. Whenever it's being fitted on K, we are creating a plano tear lens. So I'm going to explain this here in a bit. Then I want to demonstrate an RGP lens that is being fitted steeper than K. So when I have an RGP lens, remember this is my cornea here. This is my cornea. Then I want to fit an RGP lens that is steeper than K. So you can see that my RGP lens here is very steep. Now this is my limbus. So I'm fitting the RGP lens. This is my limbus here. This is my limbus. Now you can see the RGP lens is very steep than the cornea and is being filled up with a tear lens, just like I explained earlier. So these are all tears. These are tears, tear film. Then you can see that I'm creating a convex tears here. So when I pull these tears out, I'm going to have like a convex lens, which is positive. We all know that convex lenses are positive in nature. Now I have demonstrated how I created a positive tear lens because my RGP lens is being fitted steeper. Now, in a sec, I'm also going to demonstrate how I will have a flatter TLS, a minus TLS. This is my cornea again, my cornea. Then I am fitting an RGP lens. This is cornea. I'm fitting an RGP lens that is flatter than the K. This will happen here. I'm fitting an RGP lens that is flatter than the K, meaning that my RGP lens here is flat and not as steep as the other one the first demonstration. So in between the RGP lens and the cornea is filled with tears. This is one thing you should always have at the back of your mind. Did you see what happened here? That I've created a concave lens, a concave lens. So if I bring this TLS out, I'm going to have something like this. A concave TLS, which is minus. So this is just for you to understand how the RGP lens works. Now I'm going to simply demonstrate this with a prescriptions. I have a patient who came in with a spectacle RX of, let's say, minus 9.00 plus 1.50 at 90. And this same patient has a K reading. Okay, I'm going to put the prescription here. So this patient has an RX, spectacle RX of minus 9.00 plus 1.50 as is 90. Then this refracted at vertex distance of 12 millimeter. Then this patient has a K reading of 42.00 at 90, yes, at 180 and 42.50, 43, let me just say 43.50 at 90. And the RGP lens is being fitted steeper than K. The RGP lens, RGP fitted steeper than K. Is being fitted 0.5 plus 0.50 steeper than K. So the patient came in with this prescription to your clinic and wants you to fit an RGP lens for him or her. So we have this prescription. We all know this prescription is in a plus C form. As optometrists, we work in a minus C form. So step one is to transpose this prescription. Transpose, which we all know how to transpose prescription. For those who may not know how to transpose a prescription, I'm going to do that in a separate video. So when I transpose this, I will have minus 7.50 minus 1.50 at 180. Add the sphere and the seal together. Change the sign of the seal and change the axis 90 degrees apart. That is just a simple transposition for you. So this is still my RX, my spectacle RX in a minus C form. So this and this are automatically the same. Now, step 2, we have transposed this RX, but remember we are fitting, this is a spectacle RX refracted at vertex distance of 12, and this patient wants a contact lenses, which is an RGP. So this time around, we are no longer giving this patient the spectacle RX. We want to find out what is going to be this power at the corneal plane, because we are fitting contact lenses, and we all know that the vertex distance for contact lenses is 0. So I want to find out what is this minus 750, what is it going to be on the patient's corneal plane, meaning we are going to do what we call compensation. This is also what we all know. I'm not going to do that now. Maybe on a separate video, I'm going to teach you guys on how to compensate a spectacle RX to know what the power is on the corneal plane. So when I compensate minus 750 as is 180, I'm going to have 6 points. If I compensate minus 750 at 180, I'm going to have minus 6.88. For those who may not know how I got this, there is a formula to compensate an RX, just F minus 1 minus DF, which F is the power of your sphere. This is a constant, this is a constant. D is the vertex distance, and YF is the power. I'm going to simply make a separate video on how to compensate an RX. So when I compensate minus 750, I'm going to have this. Then I still want to find out, this is my new RX on the corneal plane for the sphere. Because we are working in diopter, I want to run this to the closest quarter to diopter. If I run this, it's going to be 6.75 diopter. This and this, they are the same. I just rounded it to the nearest quarter diopter. Now, I want to find out what will be my new, remember this is our sphere in the spectacle RX. So I want to find out what is this. This is our C1 in our spectacle RX. So I want to find out what will be our new cylinder now on the corneal plane. Remember here, we are looking for corneal plane. So if I'm going to, it means I'm going to transpose, I'm going to compensate this RX when it was in a minus, as it's 90 degree. Now that means I need to compensate minus 9, and when I compensate minus 9, I'm going to have, that means I'm working on as is 18 as is 90 now, minus 9. When I compensate minus 9 with that same formula, I will have 8.12. So the difference between when I compensated my sphere on the plus C form and when I compensated my seal on the minus C form, the difference between both of them is going to give me my new cylinder, which the difference between this and this will give me 1.24. When I round it, I'm going to have 1.25. So our RX at the corneal plane, we now have a new RX at the corneal plane, which is minus 6.75 minus 1.25 at 180. Because remember we transposed, so we now have our RX at the cornea, which is this. Now, and we need to fit this patient with an RGP lens of this. So this is the expected RGP RX. Now we have an RGP RX. RGP RX is equals to minus 6.75 minus 1.50 minus 1.25 at 180. Yeah, at 180. Correct. So this is what we are expected to fit this patient, the RGP RX. So automatically, this and this, they are the same, but the difference is this is the RX at the spectacle plane, the RX at the spectacle plane, the eyeglasses, while this is the RX at the corneal plane. But this is going to change in a bit. I will explain why. Remember, we are supposed to feed this patient with an RGP 0.50 steeper than K, meaning that I have a K reading here, the flattest K is 42, and they said we should feed an RGP that is 0.50 steeper than this, the flattest K. Now I have a cornea. This is the patient's cornea here, and I fitted this RGP lens. You can see the RGP lens. I fitted the RGP lens. And like I said, RGP lens, they are always filled with a tear in between. They are always being accumulated with tears in between the back of the RGP and the front surface of the cornea. So this is our cornea. This is our RGP lens. Then this is our tear lens. And this tear lens we have created is positive tear lens 0.50, and our RS at the cornea is this, which is minus 6.75 minus 1.25 at 180. RS at the cornea, tear lens. Now we want to find out what is going to be our final RGP RX. Now let's take a quick look here. If this RX here is going to bring this patient to the VA of 6.6, and I fit an RGP of minus 6 points. Yeah, before that we have what we call then our tear lens RX is going to be plus 0.50 minus 1.50 at 180. I'm going to explain this in a bit. Okay, I'm going to explain this in a bit. We are asked to fit an RGP that is 0.50 steeper than K, meaning that we are creating a positive tear lens here. So this is going to be our sphere. This is creating a sphere here. Then this minus 1.50 is coming from, this is called our corneal seal. Corneal seal, which is the difference between your two K, K1 and K2. So the difference between your two Ks gives you your corneal seal. When you do 42.00 minus 43.50, you're going to have difference of 150. Then, axis of the flattest K. The row is the flattest K minus the steepest K, and axis of the flattest K. Did you see at here, this is the flattest K 42, this is the steepest K 43.50. Now, the axis of the flattest K is 180, that is why we have 180 here. The difference between these will give us our corneal seal, and the sphere is from what we are fitting. That is how we got the tear lens. I just want to demonstrate this so it doesn't confuse you guys. Now back to our RGP lens. Now we are asked to fit this prescription on this cornea, which is, this is what the cornea needs. Do you think if I fit, and this precision is expected to get the patient as VA of 6.6. Remember, we are creating a tear lens of positive lens here. Do you think if I fit this RX on the cornea, that this patient is still going to see 6.6? The answer is no. Why? The reason is because we are creating a tear lens here, which is 0.50, which we need to compensate for the patient to get to this RX. I know it may be quite confusing, but I think whenever I do like 2 or 3 videos, some persons are gonna understand what I mean. Okay, now I have this RGP lens to fit, and I'm creating a positive tear length. So I inserted this RGP lens of this prescription to this eye. That means the patient is looking through the tear lens 1 and looking through the RGP lens. So the looking through here is looking through the corneal plate, the RGP lens, which is this, and looking through this, meaning that if I fit this, the patient is not going to have 6.75 again. The patient is going to have minus 6.25, which will not get him to this VA. Yeah, it's quite understandable. I'm supposed to fit this, and I'm creating this tear lens. That is why RGP lens is more complicated to fit. You must be a professional for you to fit an RGP lens. It's not like a soft lens when you dispense and the patient leaves your clinic. RGP lens requires a lot of calculation. Now I have created a positive tear lens, which is part of the looking through the entire viewing system. I need to compensate for this for my patient to have this correct VA, which is expected. Then, how do I do that? There is a rule we call the SAM-FAB. It is called the SAM-FAB. SAM-FAB. Steeper at minus, flatter at plus. Just an acronym for you to understand. Steeper at minus, flatter at plus. Now, we are fitting 0.5 steeper than K, meaning that steeper add minus, meaning that we are going to add minus 0.50 to our expected RGP RX, which is this. So if I add minus 6.75, yeah, and I add 0.50, I'm going to end up having minus 7.25, correct? So this is the new RGP RX, minus 7.25 diopter. Why? So what it means is if I fit minus 7.25 diopter RGP, it's going to compensate for this, for me to get to the original RX that will bring my patient to VA of 6.6. So this is TLS and RGP. Then I still want to bring this to your notice that when we are fitting for RGP, we also need to consider the base curve of the RGP lens, BOZR, base curve of the RGP lens, and the diameter. Yeah, this is correct. So the base curve and the diameter of the RGP. Now in a bit, I'm going to explain to you guys how we determine the diameter of an RGP lens. This is an eye. This is the cornea. So that's what we call the HVID. The HVID. It is horizontal visible iris diameter. Horizontal visible iris diameter. So what it means is I'm just using my PD rule to measure the distance between the edge of this iris to the edge of this iris. I'm measuring the distance between my two iris in one eye. So if I have HVID of 11 millimeter, remember how to get HVID? Just measure your iris. That will give you your HVID. So to get the RGP diameter, it is HVID minus 2. Minus 2. So some people does minus 2.5, but in Canada here, our standard of fitting RGP lens and determining the diameter is 2. So minus 2. So 11 minus 2 will give you 9.0. So this will be our RGP diameter. For any eye, the HVID is 11. Simple and short, how to get a HVID. Then I'm going to demonstrate on how to get the base curve of an RGP. Remember, initially our flattest K is 42.00 and we are asked to fit 0.5 steeper than K. So to get our base curve of this RGP lens, we are going to add 0.5 to this, which will give us 42.50. So remember, fit 0.5 steeper than K. This is our K1, our flattest K, steeper than K. So we are fitting an RGP lens that is 0.5 steeper than this, which is 42.50. So this is the steeper and this is the flattest. So since we have gotten this, to get our new RGP RX, we will do 337.5 divided by 42.50 will give us 7.94. So this is our RGP base curve. So if I still do 337.5 divided by 7.94, I will still get back to this. So if I still do this subtracted by this, I will still have TLS of 0.50. Simple and short. So this is RGP lens for you, and all you need to know about RGP. RGP lens, they are quite complex, and apart from the sound fab and compensating for the TLS and X, there are several things we need to know about an RGP lens. So like I said, just to round it up, we have our RS Adiconia plane, we have our RGP lens, we have the TL lens we are creating. Just have to know that the patient is looking through the RGP lens and the TL lens, and we have to compensate for whatever the TL lens is creating for we to give our patient the optimum and the maximum vision he or she requires. So this is it today for the RGP lens, and I'm still going to go through this again in another video for those who didn't understand what I mean. And yeah, if there's any question, you can drop that on the comment section or reach out to me via my email or private phone number. And in my next video, I'm still going to teach on how to transpose an RX and how to compensate an RX. Thank you very much.